to look at. So we will start today by going through our contents. Basically, we will going through Omega greases today. Also ITW background, Omega oils, gear oils and chain oils in particular, and food machinery products. So I want to introduce to you the background to ITW. We were founded in 1912 in Illinois, USA. We are over 100 years old. We celebrated our 100th year anniversary in 2012, so it makes us over 107 years old. We are part of the Fortune 500 company. I think this year, 2019, we're ranked around about 214. We have, as an ITW, as a company, we have over 16,000 patents. ITW employs approximately, I think nowadays there's about 48,000 employees around the world. We operate in 57 countries, and 2017 total sales revenue was about 14.3 billion. In 2019, our revenues was about a little bit improved, 14.8 billion. As I said, we operate around the world, and most of our revenue comes in three areas, regions around the world. 53% of our revenue comes from North America. Middle East, Europe, and Africa accounts for 28%, and Asia Pacific and others accounts for 19%. So, in terms of our global reach, especially our manufacturing and production sites around the world, for Omega, we have production sites mainly in a couple of regions, in Europe, in Australia. Basically, about 80 to 90% of our products come from Australia, and also Europe. And we have some products, especially not Omega, but in terms of Magna Welding, a lot of our products come from the USA. We also have manufacturing plants in Asia Pacific, namely in China. And also we have manufacturing sites in Brazil and India. Although for Omega and our other Magna brands, we don't have any products coming from these two manufacturing sites. So we'll talk about Omega next. Greases. So why do we use a grease? Well, greases are most often used instead of fluids where lubricant is required to maintain its original position in a mechanism. So a grease is expected to provide adequate lubrication and reduce friction, prevent wear, protect against rust and corrosion, and act as a seal to prevent the outside environments, water, dirt from entering the equipment, the bearings, resist leakage, dripping and fling off, and retain its usefulness when subjected to mechanical stresses and perform under a wide temperature range. So when to lubricate with a grease? When do we use it? Well, there are many various reasons, and these are some of the reasons that I've put down here, mainly to decrease the frequency of lubrication, especially in extreme locations. For example, if you have a wind turbine, wind generator, those things are, very high up in the sky, and you don't want to frequently change your oil or your grease, because it does take a long time to reach those parts in a wind turbine. You want to seal out contaminants. If you have a very dusty, or maybe sometimes like in mining or construction where there's a lot of dust and dirt, you don't want that dust and dirt being entering your equipment, so you would use a grease. Or, for instance, for intermittent operations, if, for instance, you have some generators which you're not usually using, or you have some air compressors, which you're not usually using 24 hours, maybe as a backup system. And so you're only using it for maybe a few hours or a few days during the month or year. So you use a grease. Also, you can use to suspend solid additives, sometimes, especially in construction, where we have greases which are subjected to extreme stresses and loads. You want something more than the grease to handle those stresses, and so you would use solid additives in the grease for that purpose. Extreme operating conditions, especially high temperature, high pressure, shock loading, low speed combined with high pressure. You would probably use a grease for these sort of conditions. Or sometimes when the machines are either badly worn due to maybe age, there's a lot of leakage if you're using an oil. If you're using oil for these sort of machines or equipment, there'll be a lot of leakages. So you would use a grease to minimize the leakages. And also noise reduction. Sometimes noise reduction is an important part, especially if you're in a working environment with employees there. You use a grease, and we have greases which are low noise after you apply them to the equipment. So basically, greases are used to lubricate bearings, and you can find bearings in a wide variety of equipments. And so bearings are a device to support and reduce the friction of motion between fixed and moving machine parts. So you can find them in almost every single machinery, you can see here in fans, wheel bearings, you can see here, DVDs, bikes, washing machines, etc. You can find bearings in almost everything. So what is a grease? Well, a grease is a solid or semi-fluid product of dispersion of a thickener agent in a liquid lubricant. Also in greases, apart from having a thickener agent and the base oil in the grease, you would also have additives. And these additives are ingredients which impart special properties that are included in the grease. So here you can see this is a photograph of omega 57, and you can see there's the megalite inside as well. So a grease is basically, as I mentioned, made up of three parts: the base oil, the thickener, and the additives. And we can consider a grease to be like a sponge. The pores are created by the thickener, and the pores are what holds the oil in the structure. And once we apply forces or pressure stresses to the grease, or the sponge in this instance, this analogy, it causes the oil to be released from the thickener to provide the lubrication. And once these forces or stresses are reduced or not there anymore, the oil should be reabsorbed back into the thickener. In terms of composition, thickener is approximately 2% to 30% in composition in the grease, the majority of which is the base oil in the grease, which accounts for 60% to 98%. Obviously, in the thickener, I didn't mention that you have various types of thickener content: metal soaps, metal complexes, non-soaps and soaps, and clays, etc. And the base oils, you have mineral oils, synthetic oils such as polyalpha olefin, esters, polyglycols, silicone oils, PFPE, etc. And also additives account between 0 and 10%. Okay, and as I said, these additives add extra performance enhancers to the grease, such as anti-aging, anti-corrosion, EP additives, etc., etc. So the base oil basically is used as the lubricant within the grease. They can be made of minerals, synthetic, natural oils, etc., and used in combination with the thickener, which provides the body and the structure. And these thickeners can be redefined as soap or non-soap components. The additives, they enhance the performance of the lubricant with oil-soluble components to control extreme pressure, wear, etc., as I said before. For the additives also, we can have solid components such as MOS2, graphite or polymers, calcium carbonate, and other types of solid additives. About the thickeners, well, the grease consistency, or how hard or soft, is governed by the thickener and the composition of the thickener. You would think that the base oil, being higher viscosity or lower viscosity, would have some properties for whether the grease would be hard or soft, but in fact it doesn't. We can have very thick greases, like here you can see, with very low viscosity, ISO VG100, and we could have like semi-fluid greases where the viscosity of the base oil would be quite high, ISO VG460 or higher. So you can see here the consistency of how hard or soft doesn't depend on the viscosity of the base oil. It really depends on the thickener content. If it's a higher thickener content, then the grease would be firmer, and if it's a lower thickener content, the grease would be softer. So this is the electron microscope of the grease, and so you can see here it's like a lattice network of the thickener, and between the spaces of this lattice network is where the oil, the base oil, is located, and also within this lattice network would be the additives. So there are a 3D network of fibers or particles filled with oil and no air, uniformly dispersed over a large surface area and slightly oil soluble. So there are two types, as I mentioned before, two types of thickeners. We call them soap or non-soap. And it must be emphasized that different thickener types of greases should not be mixed unless their compatibility has been confirmed by testing to the relevant applications. And obviously we have, within Omega, we have the compatibility chart, which we will go through later on. So what types are soaps and non-soaps? So you can see here, soap-based thickeners are lithium, calcium, aluminium, sodium, etc. You can have straight lithium, aluminium, calcium, sodium mixed, or complex, like complex such as lithium complex for our omega-22, or straight thickeners, soap thickeners like our omega-77, which is 12 lithium 12 hydroxy. Then there's also non-soap thickeners such as clay, such as our omega-71, polyureas such as omega-85, and others, namely like silicon dioxide based thickeners such as omega-38. So basically there are two types of families of thickeners. So obviously different types of thickeners, as you can see here, lithium complex, etc., also impart different properties. So basically lithium is not so good for high temperature applications, but very good for water resistance, mechanical stability, pumpability, and oxidation stability. Lithium complex, basically they're very good for all of these applications. Polyurea is good for high temperature, water resistance, not so good for mechanical stability, or not so good at average. And then we have pumpability and oxidation stability. Obviously, clay types and bentonite types, such as omega-71, have very good high temperature applications, and etc. For calcium types, they are very good for water resistance. Aluminium also like 57 has very good water resistance also. So you can see here, each type of different thickeners have different properties, inherent physical properties. Now we come to the additive part. Additives make up between 0 and 15% of a typical grease to enhance the lubricant performance. Additives bring properties to the grease that the thickener and the oil cannot give or cannot provide alone, or they can only provide on a limited basis. Many of these properties are the same expectations of any lubricant. So those sort of additives that you find in oils, such as gear oils, EP additives, etc., anti-rust, anti-corrosion, etc., can also be found in greases as well. Okay, so here EP greases, anti-wear, anti-rust, oxidation, friction, reduction, and adhesion. You would find these are coming from the additives. There are two types of composition for the additives. They are either oil soluble or solids. So solids are meaning solid additives such as MOS2, graphite, and others. So these additives have different types, are of different types and functions. They can be anti-wear EP agents, which reduce the friction, wear, and prevent scouring and seizure. Corrosion inhibitors and rust inhibitors, viscosity modifiers, antioxidants, etc., etc. And these are the purpose of what these additives are for and their functions. So in terms of base oils, we use the API, American Petroleum Institute base oil definitions. So base oils, all base oils can be categorized into 5 groups. Group 1 is mainly mineral oils. Group 1 and Group 2 are mainly mineral oils. Group 3 and Group 4 are what we is known as synthetic oils, such as PAO. And Group 5 are the others, which include silicone oil, polyglycols, etc., etc. So again, these base oils have their own physical inherent properties. So for instance, these are the inherent properties of the base oils, and these are the different types of base oils: mineral oils, PAOs, diesters, etc. And mineral oils, by and large, have fair viscosity index, meaning that their use for a wide range of temperatures is not so good as compared to PAOs or diester oils. Same for low temperature functionality or fluidity. Mineral oils obviously are not as good as PAOs and the other synthetic types of base oils. And you could go through each column and you could see that each type of base oil would have their own unique properties, and depending on our application, we will decide which type of base oil is used for our greases. For instance, for high temperature, we would probably we are going for PAO types. Normal operations probably would be mineral oils. So we decide. So in Omega, we basically utilize mineral oils, PAOs. We have some diesters, polyesters. We don't have polyglycols. We do have polyglycols, but not in the sense of using it as a grease, more of a carrier fluid, especially in Omega 35. Obviously, we don't have silicone oils in our greases. So base oils, we talk about the viscosity of the base oil, and viscosity is really the simplest definition is its resistance of the fluid's resistance to flow. So viscosity is a lubricant resistance to flow. Yes, the viscosity of an industrial lubricant is normally given as in the units is centistokes, or we have the ISO VG naming system, VG 32, 38, etc., etc. In Omega, we also use the SAE naming system. So SAE 5 would be ISO VG 15, SAE 10 would be ISO VG 32, etc., etc. And viscosity is the main feature which influences the efficiency of the lubricant. So in terms of real-world experience, viscosity, what does it mean? For water, normally the viscosity is 1 at a temperature of 20 degrees. And you can see here that viscosity is really governed by the temperature at which it's measured at. So for instance, like water at 20 degrees, the viscosity is 1. Milk, viscosity is 3 at 10 degrees. And for us, normally we're more used to diesel, which is approximately this viscosity of 6 centistokes at 40 degrees, etc., all the way to maybe a semi-fluid or even like hard toothpaste, which would have a lot higher viscosity at that temperature range. So this is just a ISO VG classification. You can see here VG 32 all the way to 3200. The midpoint viscosity is 32, and it also has a range. So anything between 28.8 to 35.2 viscosity centistokes at 40 degrees can be named as ISO VG 32, and each one would have a mid-range, a minimum, and maximum. As I said before, viscosity is really dependent on the temperature at which it's measured at. So at higher temperatures, here 100 degrees, obviously a liquid or an oil would have a much lower viscosity. At a lower temperature, at 0 degrees or between 0 and 50 degrees, obviously the liquid or oil would have a much higher viscosity. So viscosity is a function of a fluid is really a function of the temperature. In terms of base oil compatibility, mineral oil with mineral oil, of course, is no problem. Mineral oil with PAO, also no problem, compatible. But once we get towards these synthetics, we would have some trouble with the compatibility. So for instance, if you have a grease which is made from mineral oil, we would not recommend to mix with another grease which is using polyglycol, silicone, or PFPE. Okay? And the same for the rest. PAO is okay for these 3 types of base oils, but not so good for these 2 types. Okay, it's pretty self-explanatory. In terms of grease consistency, like I mentioned before, how hard or soft it is, this grease consistency is defined by the NLGI rating. And NLGI 000 is a semi-fluid, and it would have a work penetration of between 4,000. I think that's a mistake. I need to check again. Between I think that's probably 445 to 475. And the analogy would be ketchup, and all the way down to NLGI 6, which we very rarely see. Which has a work penetration of 85 to 115. So normally we see in industry, we have 000, 000, 0, all the way probably to 3, and then the stiffer greases 4, 5, 6 we very rarely see. So the DN value, this is like the maximum revolutions per minute that we normally recommend our greases to be used. And for something like a very stiff grease, like an NLGI 3 for Omega 57, our DN value would be approximately up to, we can use 57 NLGI 3 up to about 150,000 DN value. And for most of our greases, it's between 200,000 and 300,000 DN value. For high-speed applications, we would not recommend 3573. Basically 99, 99N, and 99FG, these are anti-seize. We would not recommend these three anti-seize products for lubrication. In terms of our greases, which greases are the best for high-speed applications, they would be Omega 66 and also Omega 85. So in terms of operating temperature, if between minus 34 and 37, depending on the speed factor, we would recommend maybe an NLGA1 all the way to NLGA2. Of course, higher temperatures, then we would normally recommend a much stiffer grease for higher temperatures. Okay, this is just a quick reference that you can use when you're going to customer. What sort of NLGI they should use. It really depends, of course, on the operating temperature and also for the speed. So low speed, high speed, depending on the NLGI. If it's a very low speed one, I would use an NLGI1, and high speed one, we would use a little bit of a thicker grease. So in terms of greasing quantity, this is a really short form method that you can use to determine the grease quantity to use in a bearing. Obviously, you have like the bearing manufacturers' recommendations. In fact, SKF has a calculation that you can use on your iPhone app. They have an application where you can enter all the details of the bearing diameter, the bearing width, etc., and then it would calculate the amount of grease you can use. But this one is just a quick calculation that you can use. But please note that this amount, the amount of grease, is in ounces. Obviously now we don't use ounces very often. We use grams or kilograms, and in the metric scale for this calculation, it would be instead of using the constant 0.114 for ounces, we would use 0.005 times it by the bore diameter multiplied by the bearing width, and that would give you amount of greases to be used in a bearing in grams. So this is how you find the bearing width, and the bore diameter is here. Okay, so I'll repeat that to use this formulation for the metrics. For metric, it would be 0.005 multiplied by the bore diameter in millimeters, and also multiplied by the bearing width, which would also be in millimeters. If you're using ounces, then you would use inches and inches respectively. So in terms of regreasing interval, how would we calculate this? Normally, again, we would use the OEM specification, the bearing manufacturer specification. So we say, for instance, we know that the bearing is a cylindrical roller bearing with the speed of 3000. The bearing diameter is 20 mm. So how would we use this graph to calculate the regreasing interval? So we would we know this is the speed, the RPM, which is 3000, and this particular graph for this one is the roller bearing. So here the diameter is 20 mm here. So 3000, we go to the 20 mm line, and then we read across, and because our bearing is a cylindrical roller bearing, so we find here the relubrication interval would be 5,000 hours. Okay, so these graphs are usually the OEMs, these SKFs and etc. They would have this sort of lubrication graph depending on what type of bearing and also the bearing diameter, and you could just look this up, or as I said, use their phone app or their online applications to calculate the regreasing interval. So yes, we would normally we can give, as a oil company, we could give an approximate lubrication interval, but we normally advise to consult the equipment builder, the bearing builder, and they should have a more precise relubrication interval for you to use, or your end users to use. So Omega greases, we have a lot. So depending on the conditions, that the operating conditions of the equipment, if it's high humidity, we would recommend these greases: 22, 57, 58, 78, 95. High load, 26, 35, 30, 33, 35, 7, 73, 77, 89. High speed, 22, 51, 66, 85. Hopefully, before I mentioned these two in particular, 66 and 85 would be our first recommendations for high-speed applications, mainly because for 66 especially, the base oil viscosity is quite low, which is more suitable for the high-speed applications. For high temperatures or extreme temperatures, high and low, we would recommend these greases: 22, 33, 35, 66, and 85. So in terms of Omega soap type greases, you can see here is our Omega grease guide. You can see here which type of thickness that we use for these greases: lithium complex, carbon black, lithium 12 hydroxy, aluminium complex, bentonite, calcium 12 hydroxy, polyurea, calcium sulfonate. So we have a wide variety of thickness in our grease range. And so obviously, depending on which operating conditions and what sort of bearings you're using, so you can select from this wide range what type of grease to use. And this also shows you the compatibility. So aluminium complex would be compatible with lithium complex, etc. And you can see here calcium sulfonate would be compatible, but borderline compatible with a grease such as 77, which is a lithium 12 hydroxy, and it would be incompatible with clay type thickeners. So here B is borderline, C is compatible, I is incompatible. So you can consult this table later on. Well, I'm sure you have you've seen this graph before, this table before. So in terms of products, Omega 77, EP bearing and chassis grease. Base oil is mineral oil, and thickener is lithium 12 hydroxy. Available in 3 NLGI grades: 00, 2, and 2.5. I think 2.5 was originally, we originally had only 2 NLGI grades, but in India, I think they requested a much stiffer grease due to the normal operating or ambient temperature, which is a lot higher in India. So they were requesting something a lot stiffer, a little bit stiffer, not a lot stiffer, but a 2.5. Operating temperature, obviously because it's mineral oil based, doesn't have a wide operating temperature, -7 to 149 degrees. So just a multi-purpose, middle of the range, this would be an excellent grease. Application would be for bearings, for high and shock loads because of its EP properties. And also one of the specific benefits for using 77 is its super tackiness, so it would stay in place. 57, which is again mineral oil based, but now we're using an aluminium complex, available in 3 NLGI grades, 1, 2, and 3, and we have a slightly wider operating temperature because of its aluminium complex, which gives it a little bit more of a boost for higher operating temperature. Lower temperature, not so, also the same as the lithium 12 hydroxy of Omega 77, -7, so not too low, but in terms of higher operating temperature, aluminium complex would be better. Same application for bearings, and as we saw from the chart before, aluminium complex thickened greases have very good water resistance and will not emulsify with water, so can be used for high temperature environments. Omega 89, which is one of our most recent additions to the Omega range. This is a multi-complex soap, which is a multi-complex of lithium and calcium, so it has the best of both worlds in terms of mechanical stability and also water resistance. It has very high 4-ball well load, 800 kg, without the use of any solid additives. And as I said, because it has calcium and lithium complex, mixed complex, they are very good for water resistance and anti-corrosion properties, and has a relatively higher operating temperature than, say, for instance, a Omega 77, which is just a single type of lithium 12 hydroxy, and it would have very good low temperature resistance, -30, compared to something like -7 for Omega 77. So it has a wider temperature range, -30 to 150, than compared to 77. So in terms of non-soap type greases, polyurea are one of our best top-selling products. Omega 77, again, is mineral oil, and thickener is polyurea, available in 2 NLGR grades, 0 and 2. We have a wide operating temperature between -10 to 230. And the main applications, again, for bearings, but mainly in terms of in LV, MV, and high tension electric motors. Also, it's proven industrial use. We have OEM approvals, customer testimonials, and case studies. And we recently came across a case study from the tire distributor who used 87, and he was able to prove that they had in operation was able to bring down the equipment temperature by maybe, I think it was over 10 degrees. Obviously, if you're bringing down the equipment temperature, you would also save a lot on power. And also, he demonstrated that using 85, they were able to reduce the noise of the bearing. And I have a video, but obviously I can't show it on here, but because of the connection, they used the before and after effect of the bearing, and after using 85, there's a significant reduction in the noise of the bearing. So if you need that video, we could arrange to maybe put it on the intranet site in the near future. In terms of synthetics, I mean the base oil types. We have Omega 22, which is using PAO. 26 to 28 is PFPE, polyfluoroether, and ester base, which is the Omega 33, and Omega 35, which is a polyglycol type of base oil for Omega 33. And the main features are obviously for PAO is the oxidation stability, chemical inertness for 26 and 28, oxidation stability for 33, and also no carbon residues for 35. Omega 22 is PAO. So now we're introducing the synthetic types of base oils for our greases, and Omega 22 is using PAO, synthetic base oil, lithium complex thickener, with solid additives, PTFE as a solid additive, available in NLGI2, with obviously, because we're using PAO base oil, it has a lot wider operating temperature, especially the lower range of -40, and the upper range up to about 210 degrees. Can be used for high loads, and because of the PAO structure, molecular structure of PAO, it resists oxidation, and obviously resisting oxidation leads to longer grease life. Some of the applications in paper, corrugated cardboard industry use a lot of omega-22. And then we have our PFBE base oils, such as omega-26. Again, this is a PTFE thickener available in NLGI2. Not so high range of, low range in lower operating temperature, -25, but has high range, higher temperature for operating at up to 280 degrees C. Chemically inert, that means there would be no changes in the grease if it's subjected to acids or alkalis, and it's non-toxic and compatible with rubber, plastic or metals, whereas we would recommend something like 26 for maybe you have plastic or rubber bearings. We wouldn't recommend normal greases for those sort of plastic or rubber bearings, but something like a 26 would be fine with plastic and rubbers. And it's used for anti-friction, plain bearings, small gears, slides, pins, valves, plungers, screws, etc. So a wide variety of uses for this grease. So we just want to touch upon possible grease failures. Some of the time we have a lot of inquiries of why is this grease failing. So some of the reasons I've consolidated, but the number one reason why grease fails is the incorrect lubricant is used. Sometimes, for instance, we have chemical industry. We have the equipment being subjected to a lot of different chemicals, gases, alkalines, acids, and a normal grease cannot withstand that sort of environment. So they're using something like a 77. Why is it melting? What's happening? So it's really because that grease cannot withstand that environment. So something like omega-26, like I said just previously, would be a more correct grease to use. Secondly, grease incompatibility. We often get this. End users are using one type of thickener grease, a competitor grease, like a clay grease, and they want to use now omega grease, which they're using something like a polyurea, and or they're using calcium sulfonate. Why is the grease failing? It's mainly because they didn't clean out, or they just used they applied omega greases to the old grease, and due to different chemistries within the thickener, and sometimes also the base oil, it would cause some incompatibility, and you would get destruction of the grease, failing maybe the grease cannot be used, and so that's mainly because of the incompatibility of the greases used. Over-greasing also because maybe the engineers don't know how much to add to the bearings. They just pump until it really fills the bearing houses, and so that's what we call over-pressurization. And then there's really no place for the grease to move around, and so that would also destroy the grease, would destroy the structure of the grease, and then you probably get the grease flowing out of the bearing, or because it loses its structure, turns to a very fluid grease coming out of the bearing. Too much volume will cause the rotating of the bearing elements to churn the grease, trying to push its way out, results in energy loss, high operating temperatures, and increases the risk of oil separation and bearing failure. Opposite to that would be lubricant starvation, when they don't use enough grease, and that's also sometimes the case where they just use not sufficient amount of grease to lubricate the bearing, and that also would have some detrimental effect to the bearing. If it's not greased enough, it would be there would be no oil or grease between the bearings, between the moving parts, and that would cause wearing and eventual breakdown of the bearing. And also some due to contamination, maybe from the environment, maybe dirt and dust and water can also contaminate the grease in the bearing, which also may cause the grease to be oxidized a lot faster, and then also would cause destruction of the grease. And so in terms of compatibility, as long as two lubricants have similar thickness systems and base oils, they should not have any compatibility issues. That's not always the case. Sometimes, apart from thickness systems, base oils, as I said, greases also contain additives. Obviously, we don't know what additives are used in the greases, especially our competitors. We don't know. And sometimes the chemistry can be also different. Additive chemistry can also be different, so that could also cause some compatibility issues. So in general, yes, as long as the thickness system and the base oils are similar, then you should not have any problems, but it's not 100%. It's important to thoroughly clean or purge the old grease from the parts to ensure the new lubricant properties are not changed significantly as a result of being mixed with the old grease. So if, worst case, if you don't know what the old grease is, the best case is to clean and purge out the old grease. You may have to open the bearing and do a thorough clean out, and then before using the new grease. Again, this is the compatibility guide that you can see. I'm not going to go through over this, but you can see this at your leisure. This is our recommended changeover procedure for mixing of greases. So this basically gives you a procedure what you can follow if you're changing over different greases. So some examples of overgreasing you can see here. The grease is really coming out of the bearing. That's adding too much grease to the bearing, and it's coming out of the bearing. You can see very clearly here. And here we can see it is the mixing of two different types of greases. You can see two different colors, which represents two different types of greases. Overgreasing you can see here also comes out the bearing, and just a waste. And it serves no purpose at all. It doesn't help the bearing, and it would be a waste of the grease. And this was what I was talking about before, about the grease being subjected to different chemicals. You can see here the grease has completely changed color due to being exposed to alkaline vapor. I think it was probably a limestone, a cement factory, where they're using lime, or a chemical factory. You can see here. So also I'd like to talk about the oil separation. Sometimes, especially for a product like Omega 77, we have sometimes you can find on top of the grease, or in the lubricators or pails or drums or the grease gun, the presence of the oil, and this is known as oil separation. But I think you need really to understand that this oil separation is insignificant when compared with the mass of grease in the container. So something like here, okay, you can see some oil separation within these in these holes of the greases. You would get more oil separation if you have the grease like this. If it was flat, the grease flat, then you would have less oil separation. So the separated oil can be safely stirred back into the bulk of the grease. So if you have this situation happening with the grease, what you can do is just use a ladle or some sort of instrument to mix back into the grease. So you don't have to use a mechanical stirrer. No, it's just used by hand, just to fold the grease over and over. And then you should see, because it's like a sponge, like I said at the beginning, the oil, once you've applied some pressure to the thickener, the oil should be reabsorbed back into the grease. Oil separation is time related, so oil separation can be reduced if the surface of the grease is kept smooth, and also because sometimes, like I said, time related. After long storage, sometimes the grease sometimes the oil can come out of the grease after a long storage period. Can also be found in grease guns, especially idling for a long period of time. So usually, if we were to pour the oil out of this, it wouldn't be a lot compared to the amount of oil that is in the grease. So it might look not so nice, but it would not cause any performance issues with the grease. As I said, the volume of oil coming from oil separation of the grease is relatively small compared to the mass of oil in the grease. Okay, so it's nothing really to be worried about, unless, of course, if this whole area of the top is completely, if you see, like, maybe in a grease pail you see maybe a very high layer of oil, then maybe there could be concern there, but I very rarely see that sort of case. It would just be like small puddles on top of the grease. Omega oils. So now we're talking about oils. We've finished greases. Like I said, if you have any questions, please jot them down. And then at the end of the webinar, we can have a 10-15 minute session for Q&A. And so lubricating oil. Lubricants are composed of base stock or base oil and the addition of performance enhancing additives. The base oils usually account for approximately 75% to 85% of the oil, and the additives between 15 and 25%. So base stock plus additives is lubricant. So the difference between the grease here, what we're missing is the thickener. So in terms of lubrication of gears, gears we can find again in many different types of everyday items, from watches to your bicycle to huge open gears found in the mainly in the cement industry. Different types of gears: spur gears, bevel gears, helical gears, plancher gears, herringbone, and these are basically, these 8 types make up most of the types of gears that we can find. Used in all types of industries, from agriculture, automotive, sugar, cement, chemical, so many more. So almost every type of industry you can think of has some type of gear applications. So gears are used to reduce the coefficient of friction between the gear teeth to limit the temperature rise caused by rolling, especially from sliding friction. This is particularly in worm gears, where it's mostly a sliding friction. And to improve efficiency of the gear units, the correct gear oils must be chosen. For Omega, we have both grease products and also oil products. So grease products, that would be something like Omega 64 and Omega 73 for the open gears. And then we also have food grade NSF H1 gear oils, 585, 588, and also our mineral gear oils, 670, our worm gear oil, 680, and for our industrial gears, something like Omega 690. In terms of greases, Omega 64, pin and bushing and track roller grease, mineral oil based, 00 semi-fluid, ultra tacky service range, or temperature service range between -7 and 149, and provides extended service as compared to ordinary greases. Can be used in slow moving industrial gears, or, for example, open gears where fluid grease is required. Omega 73 we use for open gear greases. It's fortified with solid lubricants, graphite and MOS2, available in NRGi 2, and it has exceptional resistance to water wash-off and temperature range, operating range between -8 and 200 degrees C. So you can use these in open gears or cranes, water pumps, winches, timber drags, etc., rotary kilns, mills, cement plants, etc., etc. It's also been approved by NEG Micon, which is now Vestas, for the use of the external yaw system of the wind turbines. In terms of oil, especially for the food grade food industry, we have Omega 585, which is synthetic based, PAO based, VG 226-460 is NSF H1 approved. Extremely adhesive lubricant with excellent protection against water wash-off and a wide operating temperature between -30 and 240. Used for all gear units used in the food and beverage industry, and also it's been approved by David Brown. Our most recent addition is our Omega 588, which is, apart from having NSF H1 approved, it is also halal and kosher approved. Meets FDA, obviously it meets FDA 21 CFR because it's H1 approved, and also it's manufactured in a facility which is ISO 21469 approved. It's also approved for industrial use as well, so it meets and exceeds DIN 51517-3 CLP and also ISO 12925-1 CKB. Based on PAO technology, the base oil is obviously PAO, and it can be used for multi-purpose lubrication, hydraulic circulating systems of medium to low loaded bearings. Recommended operating temperature between -35 and 160. So this is the pack shot of Omega 588, and the oil slightly yellow. Omega 670 is a straight mineral oil. So what I mean by straight mineral oil, it's just only the base oil. There's no additives in this particular gear oil. Some applications require just a base oil without using any additives. So this is a gear oil for those sort of applications, suitable for lubricating and protecting gear units where non-EP oils are required. 680 is used for worm gears. It's formulated with mineral oils. Mineral oil is the base oil for 680, and formulated with solid lubricants to provide protection for elevated temperatures up to 400 degrees C. Available in VG 220 and 460, and can boost efficiency of worm gear sets by 8%. It can also be applied on bevel and spur gear units, and recommended by David Brown. And of course 690, which is our super EP gear oil. We have mineral oil and PAO based 690. The PAO based 690 are normally used for automotive gears, and the mineral oil based are for industrial gears. Available in VG 150 to 460, and the multigrades for the automotive applications are 75W90 and 75W140. So those ones are PAO based. So they surpass GL5 and GL6, and suitable for both industrial and automotive gearboxes. Super techy, obviously, because you have the beta test. You can demonstrate to the end users, and has proven OEM approvals and customer testimonials and case studies. So these are just, the following slides are just the OEM approvals and customer testimonials. I won't go through them each one, but you can see, for instance, Omega 73, which was originally approved for MHE Micon, and now MHE Micon has been merged with Vestas or been bought by Vestas. David Brown gearbox manufacturer approved lubricants list. We have Omega 585, 670, 690, 680 and 690, which are on the approval list. And then other equipment manufacturers which also have these approvals. So you can go over these at your leisure. Next, we'll talk about the chain oils. So chain oils, there are basically three types of chains. There's precision roller chains at the top here, silent chains, which basically are exactly the same, but the spaces in between are filled, so create less noise. And then we have specific engineered steel chains, which are basically the same, but specially engineered for the application. Factors to be considered when choosing a chain lubricant, whether those chains are under high loads, does those chains, if under high loads, are they elongated? Elongation happen on those chains. So therefore, if that is the case, we normally recommend chain oils with EP additives or very high viscosity base oil, or high load carrying capabilities of the chain oil is required. Sometimes we have to understand whether the environmental conditions, whether it's a corrosive environment, there's moisture, or there's dust, and chain oils with excellent protection against corrosion and rust are required or recommended for these type of environments. Chain oils with good adhesiveness, and anti-corrosion additives required for chains exposed to moisture or wet conditions. Greases are preferred for chains exposed to dusty environments. Again, that's because that greases can seal the chains from being exposed to those dusty environments. In terms of temperature range, normally if those chains are subject to different temperature ranges. So medium to high temperature would be between 160, high temperatures between 160 and 300, and extreme temperatures would be something over 300 degrees C. So for lubrication of chains operating at temperatures greater than 160 degrees centigrade, ordinary chain oils are not enough. So therefore we must use special chain oils, such as those fortified with solid lubricants or synthetic base oils are required. So speed versus viscosity general rule only. Please consult OEM recommendations or TSD departments for detailed information. So normally, as a general rule of thumb, higher speed chains require low viscosity chain oils, and slower chain speeds would normally require higher viscosity. So these slower chains are normally carrying maybe heavy loads, so that's why they're a lot slower. And so we would need a much higher oil, much thicker oil thickness of the oil to meaning high viscosity to withstand that sort of loads. And also you have to take into account, apart from the speed, you also need to take into account, as I said before, the operating temperature, whether it's greater or less than 160 degrees. So for instance, if the temperature range is very low, ambient temperature, or -5 or something, like a chain oil, which is a VG46, would be more suitable. So if you have a lot of temperature, a high temperature up to 160 degrees, we would recommend a high viscosity chain oil, something like a 320. So normal operation is between 50 and 100. So VG100 or VG150 would be more suitable. So the selection of the chain lubricant, as you saw before, in Omega we have a selection of both greases and oils. So commonly chains are lubricated with oils, but greases can be used sometimes if there are grease fit devices to the chains. Greases are applied in some instances to shield out contaminants, especially in the very dusty or dirty areas, for chains operating in open areas. Others to consider if you need food-grade lubricants required due to stringent requirements of the food and beverage industry, something like an NSF-approved chain lubricant or a chain grease is required. For much higher temperatures, if the chain is subjected to a lot higher temperatures, you would probably need a chain lubricant which has solid lubricant. So solid lubricants are included in the lubricant to provide extra protection to the chain, usually utilizing the dry lubrication on the chains at elevated temperatures. What I mean by this is, say for instance, we know that mineral oils can only withstand up to maybe 200 degrees. Definitely over 230 mineral oils normally cannot withstand, and they start to decompose. So once that starts to happen, you have nothing really lubricating the chains. So that's why they have to rely on the solid additive to provide some sort of dry lubrication to the chain. The oil-based fluids act as carrier fluid of the lubricants at elevated temperatures. So some chain lubricants, they only use the oil, especially if they're using polyol esters as a carrier fluid. Polyol esters have some limited lubrication to the chain at lower temperatures, but once high temperatures occur above maybe 250 or if we're approaching 300 degrees C, those sort of base oils, the carrier fluid, polyol esters, will evaporate or flash off. So you're only left with the solid lubricant to lubricate the chain. So some types of solid lubricants that we use include graphite, MOS2 and PTFE. So added values of graphite and MOS2, for instance, in Omega 646, we use some solid additive in the formulation. So these sort of products are effective up to 400 to 450 degrees C. And due to the laminar structure of these solid additives, they have excellent lubricity, good resistance against shear stress, and hard to be squeezed out under high pressure. So if you have application end users which is very high temperature, it's best to use Omega lubricants formulated with solid lubricants, or you can consult our TSD department for further information. The synthetic types of synthetic-based chain lubricants. Synthetic base oils are man-made base oils for chain lubricants. They have been scientifically designed to improve physical and chemical properties. Synthetic oils of the chains include synthetic ester oils, PAOs, polyglycols, etc., and PFPE as a base fluid also for chain greases. Synthetic base oils have a much higher viscosity index, meaning they can withstand a much wider temperature range. And also some synthetic base oils have a low tendency to carbonize. So like if you're using a mineral oil-based chain lubricant at very high temperatures over 250, once the mineral oil starts to decompose, it would carbonize. And once it carbonizes on your chains, then it would cause blockages. Those carbon cannot be, it will not fall away. It will stick to the chains. So that's why you have to use synthetic base oils which have low carbon when they are subjected to higher temperatures, such as the previously synthetic esters or polyol esters, which would give a lot less carbon, or leave a lot less carbon once they start to decompose. High temperature stability, maintain high performance at high temperatures, high lubricity, protection of the gears of the chains against wear. Again, if you need information on what sort of synthetic chain oils that you should use, please consult us. And next would be features and testimonials. Oh, no, I don't think so. I think I took those out to save time. In terms of our product offer in Omega, we have Omega 65, and also, as I said before, we also have the oils, Omega 585, 588, 641, 642, and these would be food grade. And then we also have the other 642, 608, 646, 647, 648, which is the other chain of oils. 65 is the long life chain and cable grease, which is our grease offerings for chains. It's fortified with graphite and available in the semi-grease NLGI 00 for better fluidity and penetration into especially the grease chains. And it's very tacky, so resists fling off. Surface temperature between -29 and 149 degrees C. Can be used for hoists and lifts of chains, also suitable for wire ropes and crane cables. 641, Omega 641 is used for food and beverage industry. It's food grade, approved, NSF-H1 listed and approved and available in ISO VG 220. Extremely adhesiveness. It's known for its adhesiveness and has excellent protection against water wash-off. Has quite a good temperature range for operation between -10 and 280. And this, because it is made of synthetic ester, it leaves little or no residue on the chain once it's subjected to higher temperatures. Okay. This one, 641, doesn't have any solid additives, so it's all coming from the synthetic base oil and the addition of the additives in the formulation. 642, which is apart from being NSF H1 approved, it's also halal and kosher approved, meeting the various FDA 21 CFR and ISO 21469. Again, this is synthetic ester based with also additive technology, formulated with both ester and special additives, and it has the properties of being high temperature, low residue chain oil for oven chains, operating conditions between -15 and 240. It's available in two viscosity grades, VG68 and VG220. And you can see here, there's a slight difference in temperature, operating temperature between the two viscosity ranges. 608, which is the whey and chain oil. This is mineral oil based with the Omega Megalite additives added to it. Available in 3 viscosity grades, VG 100, 150, and 220. EP additives it also contains. Has exceptional emulsive quantities and maintains lubrication even under extreme wet conditions, and surface temperature between -15 and 160. suitable for industrial chains, also for everyday items like bicycle chains, motorcycle chains, trolleys, and machineways. 646, which is a mineral oil-based chain lubricant with MOS2, available in 3 viscosity grades: VG68, 150, and 220. And due to the presence of MOS2, it would rely on dry lubrications, especially at temperatures over 300 degrees up to 400 degrees. Formulated with special additives to cope with the stick slip commonly occurs in slow-moving, heavily loaded chain equipment. Because, again, it contains the mineral oils, you would get carbon residue at very high temperatures, so we would recommend periodic cleaning of the chains to keep them in optimal condition, and also suitable for most types of chains and conveyors. 647. 647 is using polyol esters and base oil, so it would leave no carbon residue on the chains at very high temperatures. It's formulated with MOS2, meaning at temperatures above 300 up to 400, the MOS2 would be the additive or which is used to lubricate the chains, because at that elevated temperature, the synthetic base oil would have already evaporated, but the good thing about this, there would be no carbon residue, and there would be low smoke at those higher temperatures. So there would be little need to clean the chains, because there wouldn't be any carbon residue on the chains if they were using 647. It adheres tenaciously to the chains, and it has excellent anti-corrosion properties. And 647 is especially suitable for high temperature applications on chain drives and conveyors where cleaning is not possible or desired. Smokeless, again, this would be 100% synthetic base oil, available in VG150. So this would have smokeless, whereas 647, you would probably have some low smoke at those elevated temperatures, but 648 would have no smoke. So, and sometimes, end users at those high temperatures, if they see some smoke, they get very concerned. So that's why there's Omega 648. Because at those high temperatures, there would be no smoke on the chains. Here, 648, but because there's no solid additives in 648, it could only withstand up to temperatures of 270. So once 270 is surpassed, then all of this would evaporate or flash off, as we call, and then there would be nothing lubricating the chains. So this is effective if you really want to maintain super cleanliness to the chains in operation. Specifically ideal for chains operating at high temperature in a clean environment. So this is just a summary of our products, description, which ones are synthetic base, which ones contain solid additives, which ones are food grade, and which is halal and kosher approved, and some of our end users. Okay, so that completes the chain lubrication. Next would be Omega food grade lubricants. So what is a food grade lubricant? It's maintenance products for use in the food or other clean industries. These products contain no toxic or harmful ingredients and not usually designed to come into direct contact, but no health problems if they do have accidental contamination of the food. So that's very important. I think sometimes there's some misleading information about NSF-H1. NSF-H1 is for use in the food industry with incidental contamination. So it doesn't mean it can come into direct contact with food. It means no harm would come if the grease or the oil was if it accidentally contaminates the food. There are NSF-3H products which can have direct contact, but those are mostly used for the mold release sort of products, where there would definitely be direct contact between the product, the grease or the oil, with the food. But for our case, for Omega oils and greases, ours are H1, meaning only used for accidental contamination of the food. So a summary of our food grade products: 26, 38, 58, 68, 78, and 99 FG. The base oils, solid lubricants, which one? Obviously, they're all H1 approved, but only 68 here is halal and kosher approved also. Omega 58. I bring this up because we recently, in 2017-18, we started to change the source of this product. So the reason why we had to change is because you can see the old product here is like a Snow White sort of appearance. Well, obviously, to get that Snow White appearance, you have to use some additive to get that appearance. And that additive that we used, or that chemical or substance we used, was zinc oxide. And zinc oxide is a heavy metal, and so it was started to be banned the last couple of years from formulations of this type of product. So we had to use a different additive. Obviously, the result is not as good, not as white, it's slightly yellow, sort of brownish sort of color. But it's unavoidable. It is nowadays as countries and regulations becomes more and more stringent. We have to follow suit, or else we cannot sell the product. So it was updated formulation in 2018. So a non-zinc oxide formulation. Now it's manufactured in the UK and uses synthetic base oils, PAO, and contains PTFE also as a solid lubricant, 0 and 2 available, NLGI grades, H1 approved. So recommended operating temperature between -40 and 165. And there's another thing I would like to point out, especially you can see very clearly in this photograph, the presence of oil separation. This usually occurs with products which contain solid additive PTFE. So something like an Omega 28 or 26, which also is PTFE based, would also have this phenomenon. As I explained during the grease section of this presentation, oil separation is a natural occurrence, and the way to minimize the effect, especially when the product goes to the end user, is just to use a ladle or some sort of mixing instrument and manually fold the oil back into the grease. Once you do that, there's pressure on the thickener to reabsorb the oil back into the structure. So that you will see, especially if you open a new pail after a long storage, you would see some evidence of oil separation in the grease. Also, Omega 68, which is a relatively new product for us, which is NSF H1 halal and kosher approved. And also, it's based on white mineral oil, and thickener is calcium sulfonate. So it's very good for extremely wet conditions. Operating temperature between -40 and 200 degrees C. So you can see here, the appearance of 68 is like something like a 78 and a 95, because basically They are the same calcium sulfonate thickener, slightly creamy, off-white appearance, yellow appearance, sorry. So in terms of oils, we have 580, 585, 588, 609, 615. 588 is our machinery oil, which is, apart from being NSF H1 approved, it's also halal and kosher approved. 580 is white mineral oil based. 585, 588, 615 are PAO based. 609 is also white mineral oil based. 638, 641, 642. This is the penetration oil for the food and beverage industry, F&B. 641 is just the chain oil, and 642 is also the chain oil. But the difference, major difference, is that 642 is also halal and kosher approved. So 588 is NSF H1 halal and kosher approved, meets and exceeds ISO 6743-4HMHV, also DIN 51524-2HLP and 51524-3HGLP, and these are basically for the hydraulic oil specifications for industrial hydraulics. They are PAO based, and you can use them not only in the food and beverage industry, you can also use them in the industrial hydraulics because they meet these specifications. Operating temperature minus 35 to 160 degrees C. You can see here the pack shot and the oil, which is slightly darker yellow. And these are the approvals that we have for these products from halal and kosher. So only these products are halal and kosher approved. 68, 588, and we have another product in Corium, which is the Corium 131, which is the aerosol grease, which is also approved by halal and kosher. If you want to search the official listings of our NSF approval letters, or sometimes your end user need the letters for their audits, you can download them directly from the following web address. So you would go onto the web, and you can click this link to your web browser, and then search under ITW PPF Korea. And then once you find the company name, then you can search by product, and you can click the product to download the letter from NSF H1. So that concludes our presentation, and thank you for joining us for this presentation today. And